Now let us continue flywheel and turning moment. See, we discussed already the purpose of the flywheel in an engine. The flywheel absorbs energy when there is excess of energy, and it gives out its energy when there is a requirement of energy. During power stroke, there is excess of energy. So during power stroke, the flywheel absorbs the energy as kinetic energy, and during other strokes it gives out its energy, that is during suction stroke, compression stroke and exhaust stroke, it gives out its energy and drives a piston. Therefore, the flywheel reduces the fluctuation of energy in an engine by absorbing the energy when there is excess of energy and by giving out its energy when there is a requirement of energy. Therefore, it reduces the fluctuation of energy. Therefore, what is coefficient of fluctuation of energy? Coefficient of fluctuation of energy is equal to CE. It is the ratio of the maximum fluctuation of energy to the work done per cycle. Maximum fluctuation of energy to the work done per cycle. Delta E is the maximum fluctuation of energy. Work done per cycle is equal to T mean turning moment, mean torque into theta, crank angle turned. Theta equal to 4 pi radians for 4-stroke engine, that is 2 revolutions. Theta equal to 2 pi radians, that is 1 revolution for 2-stroke engine. That is, in 4-stroke engine, every 2 revolutions constitute 1 cycle. Every 2 revolutions have 4 strokes. Right. Now, I told you already, the energy of the engine increases. When the energy increases, the speed increases. So, N1 is the maximum speed of the engine in RPM. N2 is the minimum speed of the engine in RPM, revolutions per minute. What is coefficient of fluctuation of speed? Coefficient of fluctuation of speed, CS, is equal to maximum fluctuation of speed to the mean speed. Maximum fluctuation of speed is maximum speed minus minimum speed. Divide by mean speed is maximum speed plus minimum speed divided by 2. Therefore, coefficient of fluctuation of speed, CS, is equal to maximum fluctuation of speed divided by the mean speed. Therefore, N1 minus N2 divided by N. N is equal to mean speed, N1 plus N2 by 2, mean speed. CS, coefficient of fluctuation of speed. N1 minus N2 divided by N1 plus N2 by 2. Right? So you can write 2 into N1 minus N2 divided by N1 plus N2. You can write like this. You can also write like this in terms of angular velocity omega. Omega is the angular velocity. You can also write like this, 2 into omega 1 minus omega 2 divided by omega 1 plus omega 2. Where omega 1 is the angular velocity at maximum speed. Omega 2 is the angular velocity at minimum speed. Right? So you can write like this also. You can also write like this, CS is equal to 2 into V1 minus V2 divided by V1 plus V2, where V1 is the tangential velocity of the flywheel at maximum speed. V2 is the tangential velocity of the flywheel at minimum speed. Right? You can also write like this, because V is equal to, we know the formula, V is equal to R omega. Therefore, we can write omega is equal to V by R. Right? V, tangential velocity, is equal to radius of gyration, radius into omega angular velocity. From this, omega equal to V by R. So when we substitute V by R, we get like this. Okay, omega. So using this formula, you can write these two. M is equal to coefficient of steadiness. So this is another formula. M is equal to 1 by coefficient of fluctuation of speed. M is equal to 1 by coefficient of fluctuation of speed. Right. Next we can write energy stored in a flywheel. Energy stored in a flywheel. M is equal to, let M equal to mass of flywheel in kilogram. K equal to radius of gyration. Radius of gyration in meters. So I is equal to mass moment of inertia. I is equal to mass moment of inertia about the axis of rotation. I is equal to mass moment of inertia about the axis of rotation. Therefore, I is equal to mk square. This is the general formula. I equal to mk square is the formula. Mean kinetic energy of the flywheel is equal to E. E is equal to mean kinetic energy of the flywheel. So E is equal to half I omega square, where I is the mass moment of inertia about the axis of rotation of the flywheel. Omega square is the mean angular velocity square. So I can write E is equal to half mk square. Substitute that, mk square omega square. Then maximum fluctuation of energy del E. Delta E is the maximum fluctuation of energy. Maximum kinetic energy minus minimum Ke. Maximum fluctuation of energy delta E is equal to maximum kinetic energy of the flywheel minus minimum kinetic energy of the flywheel. Therefore, we can write half I omega 1 square, because kinetic energy is half I omega square. Half I omega 1 square minus half I omega 2 square. Right? So therefore, this is equal to half I into omega 1 square minus omega 2 square. This is the maximum fluctuation of energy del E. Therefore, maximum fluctuation of energy del E is equal to half I into, you can write omega 1 plus omega 2 into omega 1 minus omega 2, a square minus b square, a plus b into a minus b. So I can write del E is equal to maximum fluctuation of energy del E of the flywheel is equal to, I can bring this I into omega 1 plus omega 2 by 2 into omega 1 minus, I can write like this, omega 1 plus omega 2 by 2 into omega 1 minus omega 2. This is nothing but the mean speed. Therefore, del E is equal to I into omega 1 plus omega 2 by 2 is omega I omega into omega 1 minus omega 2. Multiply and divide by omega. I into omega divide by omega into omega 1 minus omega 2. I multiply and divide by omega, right? Therefore, it becomes I omega square into omega 1 minus omega 2 divided by omega, right? I omega square, right? Multiply this equation, multiply and divide by omega. So it becomes I omega square into omega 1 minus omega 2 by omega. Omega 1 minus omega 2 by omega is nothing but maximum fluctuation of speed, right? Therefore, del E is equal to maximum fluctuation of energy is equal to I omega square Cs. I omega square Cs, right? Therefore, E is equal to, we know that E is equal to, we have already derived E is equal to half I omega square. Half I omega square. Therefore, 2E is equal to I omega square. Substitute this, you will get del E is equal to maximum fluctuation of energy is equal to 2E. This is del E is equal to half I omega square Cs, right? Therefore, I omega square is 2E. Therefore, 2E Cs. 2E Cs. This is the equation. Maximum fluctuation of energy del E is equal to 2 into mean kinetic energy stored in the flywheel into coefficient of fluctuation of speed. So this is the derivation.